Well, in this video we're going to be continuing where we left off in the previous one, still talking about quadratic equations and quadratic modeling. But you might wonder, well, when are we ever going to use this, or what would be a real-life scenario where we would have any application for what we just talked about? Well, one such example is illustrated here with the height of an object formula. The height of the object, you're not going to have to memorize this formula, but you want to know all the parts to it. I'll give you the formula, but you'll want to know what each of the individual pieces represent. So the actual formula is negative 1/2 times our value of g, which we'll talk about in a second, t squared plus v sub 0 times t plus h sub 0. Now let's talk about those individual parts. Let's start with the value for g. G is your acceleration due to gravity, and we have actually two different values that we could use for g. If we're dealing with a story problem and all of our measurements are in feet, we're going to use 32 feet per second squared as our value for g. And the feet per second squared, the actual units, you don't put into the equation, but the 32 is what we would use for g. And half of that would be 16. So we'd actually start out with negative 16 times t squared. Now, if our units in our problem are all in meters, then we would use 9.8 meters per second squared. And half of 9.8 is 4.9. So we would have negative 4.9 times t squared. Now let's talk about the other pieces. Now we have the v sub 0. That v sub 0 represents your initial velocity. So we would put whatever that value is into that next term in the equation. And then our last term, our constant, is going to represent your initial height, how high the object is being thrown. And if it's from the ground, our initial height would be 0. So it's how high above the ground that we're throwing or launching the object. So let's look at a specific example now where we will use this formula and use some of the parts that we were talking about in the previous video. So it says using the formula where we just talked about, and g in this case is going to be 9.8 meters per second squared. I had a typo in my worksheet there. It should be 9.8. Find the relationship between the height and time when a ball is thrown upward from a height of 15 meters and initial velocity of 20 meters per second. So now we're going to basically, when it says find the relation, we're just looking for the equation here. So our equation is going to be h equals negative, and we're going to take negative 1/2 of g, so 1/2 of 9.8 is 4.9, so it'll be negative 4.9 t squared. I'm going to use capital letter t's just so they don't get confused with pluses. So we negative 4.9 t squared plus our initial velocity. Our initial velocity, they say right here, is 20 meters per second, so it'll be 20 t. So you got to be careful. You want to make sure you read these carefully, because just because a 15 came first in the story problem doesn't mean it's what we put in next. So you want to make sure that we read this carefully and find the initial velocity and put that as your second term times t. Then it's plus your initial height of 15, so it'll be plus 15. So there's your equation. So to answer part B, when it says find the height of the ball after 3 seconds, we just put 3 in for t. So it'll be h equals negative 4.9 times 3 squared plus 20 times 3, or 60, plus 15. Plug it in your calculator and you're going to get a value of 30.9 as your answer. We want to make sure we include units, so since everything's in meters here, our answer is going to be 30.9 meters is how high the ball would be after 3 seconds. Now it says, when will the ball hit the ground? Think about that for a second. What term did we talk about previously that would tell us when the ball would hit the ground? Well, if you think about what we have here, you're throwing the ball from a certain spot, and where it hits the ground is going to be your x-intercept. Now, remember, we would have, if we have a parabola, we would have two x-intercepts. The negative value, this one over here, we would not care about. All we care about is where it's going to be a positive value for your x-intercept. So to find that, we still have to use our quadratic formula. So it's going to be x equals the opposite of b, and again I'm using this equation that we have here. So it's going to be x equals the opposite of b, so negative 20, plus or minus the square root of b squared. Well, 20 squared is 400, minus 4 times a, which is negative 4.9, times c, which is 15. Remember, it's going to be everything divided by 2 times a. A is negative 4.9, so we'd have negative 9.8. So now I'm going to just take and simplify what's under the square root. If on my calculator, if I take
400 minus 4 times negative 4.9 times 15, I get 694 as my answer. If I take the square root of that, I'd end up with 26.34. So it'd be negative 20 plus or minus 26.34 divided by negative 9.8. Now I got to figure out, well, what's going to be my x-intercept? When is it going to hit the ground? Is it going to be negative 20 minus the 26.34 or negative 20 plus the 26.34? Well, let's start with the plus. Negative 20 plus 26.34 is going to give me 6.34, which divided by negative 9.8 will give me a negative number, which is the x-intercept I don't want. Where if I take negative 20 minus 26.34, I have negative 46.34, and divide that by negative 9.8 is going to give me a positive answer. And that positive answer is going to end up being 4.73. You want to make sure that we put our units here. It's not going to be 4.73 meters because it's asking when will the ball hit the ground. Our x-axis is representing the time, and our y-axis is representing our height. So this would be 4.73 seconds is your answer. Let's work on this next one together as well. It says a projectile is shot from a tower 10 feet high with an upward velocity of 100 feet per second. Approximate the relationship between the height and time after the projectile is shot. So again, when they say approximate the relationship, we're just coming up with an equation. So it's going to be h equals, this time everything is in feet, so our value for g is going to be 32. Well, half of that is 16, so it'll be negative 16 times t squared, plus your initial velocity. Our initial velocity is 100 feet, so it'll be 100 t, 100 feet per second. And our initial height is that it's being launched from 10 feet high, so it'll be plus 10. So there's our equation. Now, this one here is asking for what is the ball's maximum height. Now, we've got to think again. What would they be asking for here? What term are we trying to find from that previous video? Well, if you said the vertex, that's exactly right. So we're trying to figure out what is the vertex. But remember, the vertex is a coordinate. It's a coordinate x and y. Remember, x is representing the time and y is representing the height. So really what I'm trying to find here is I'm trying to find the y value for my vertex. But in order to do that, I still need to find the x value. Remember, to find the x value, we take the opposite of b over 2a. Again, that was in the previous video. So the opposite of b, the opposite of 100 would be negative 100. And 2 times negative 16 is negative 32. Well, if I do that on my calculator, I'm going to get 3.125. Now, they don't ask us what this represents, but again, what this would represent is it would take 3.125 seconds for the ball or the projectile to reach its maximum height. Now we have to figure out, well, what would that maximum height be? So to find that out, we're going to put 3.125 in my equation. And when you plug that in your calculator, we end up getting 166.25. And again, we need to include units for the story problem. And since everything's measured in feet, this means the maximum height would be at 166.25 feet. So that is an application of a quadratic model. And so in the next video, we're going to see how to be able to come up with the equation if we're given some points. We are not going to learn how to do this by hand. It's just too time consuming and it's not something that you're going to be evaluated on. But you do want to make sure you know how to use your calculator to come up with a quadratic regression for points. So with that, we will stop this video, and so make sure to watch the next video so you can learn how to do that piece on your calculator.